Sir, good morning. I am getting our Teams meeting up and running. We've got a couple people calling in that couldn't be with us in person today. If that'll work. Can you guys hear me okay? The microphone? A little louder? Okay. Good morning. We've got some folks on the call as well. Can you guys hear us?
Yeah.
I think we're good. So for those on the call, you guys might have a little bit of trouble here in the gallery. We're unfortunately tied to audio here at the laptop, but Mike Kurtz did say good back.
Okay.
You just couldn't hear him. So awesome.
No.
We got you, Kurt.
My
Awesome.
computer, something weird.
Okay, well, good deal. Well, folks, we'll go ahead and get started here at City Hall. We've got a couple people join in. Camilla, would you mind letting people into the lobby if I walk away from this?
Absolutely.
Awesome. Thank you, ma'am. We'll go ahead and get started here. Okay. Everybody's got us on the TV? Perfect. Awesome. Well, sorry about that, folks. We're getting everybody up and running this morning. Jordan Quarrier, project manager with Ardura. We've got, you guys hear me okay? Maybe? A little louder? Okay. We've got our project team out of Oklahoma City with us. So we've got Crystal Kowalik, our client service manager. We've got John Levitt, our project director for the Central Region. Kyle Drury, our group manager out of Oklahoma City. And Connor Wigington, our project engineer on the project. And we've also got some other folks on the call. We've got Ozzie A., our electrical engineer, Brandon Price, our structural engineer, as well as Safar Sahar, our INC and control and instrumentation engineer. I think we've got a couple faces we haven't had a chance to meet in person just yet. For those of you that haven't met us, we're Ardura engineers out of Oklahoma City. We're a multidisciplinary civil engineering and environmental engineering firm. And we've been very fortunate and grateful for the opportunity with City Guyman to work with them on the multi-phased project that is Mesa Water. So, awesome. Anything else, Mike, before we get into it?
Proceed.
Awesome. So for you guys that have been keeping up with Mesa Water project, it's been a multi-phased project starting with the test holes as part of phase one. Phase one was the confirmation test well program that we completed late 2024 into early 2025. It involved 7 test holes that we drilled up in the well field about 7 miles northeast of Guyman. As part of the test holes, we collected subsurface lithology information. and groundwater sampling to determine the quality of water as part of these wells for proposed public water supply. And the results were great. So as part of those 7 test holes, we recommended to the city that we'll go ahead and build out the well field for public water supply, and that is phase 2, the production well field improvements. So this first deliverable in our design package is for 60%. At 60%, this phase 2 production well field improvements includes all major design components for building out and developing the wells, as well as the surface completion and well collection discharge piping up inside the well field. Phase 3, we are also working on concurrently right now, which is in 60%, which includes the water delivery system, which will be the final transmission of that pumped water collected from the well field about 3.5, 4 miles west to the booster pump station and ground storage tank location, which is on the city property just north of Cactus Booster T, and then final transmission and distribution back to town for final delivery of water into the Guyman system. So as part of phase 2, we've got our 60%. Let's see if our clickers will work through here. So under 60%, let's see if I can get you guys maybe a little bit zoomed in. Oh no. Probably not while we're in presenter mode. Let's
Hey
see.
Jordan, I'm not sure if we're trying to show the people on Teams, but we can't see. We don't have a shared screen.
Okay, let's go ahead and do that real quick. Thanks, Camilla. And Camilla, I do apologize, you were online as well. Camilla is our resident hydrogeologist and project engineer as part of developing the wells too. Can you guys believe I forgot Camilla? She was definitely a fan favorite when we were up here for a couple months doing the test hole, so I do apologize. Okay. Yeah, she will. She's a kind heart. Okay, everybody got you now? Can you see it? Take that as a yes. Okay, so up at the wellfield site, we've got the location for the 7 test holes. We've got 6 that we're proposing to be developed out as the proposed production wells. We've got 1, which was the last test hole we completed back in November, December. That one will be permanently plugged, taking a look across the project site for stormwater drainage path. That one's just too close and in the way. So we will have at least 1 that'll be called for permanent abandonment in the well field. See. So taking a look at the 6 sites across the well field, we've got a alignment for the well field collection pipeline, which will be the pumped water out of the wells, which will be collected on site and conveyed to the southwest corner of the well field. That's going to be the limit of the phase 2 construction as part of the pipeline improvements. And we'll pick up as part of phase 3 outside of the wellfield property for final transmission back to the ground storage and booster pump station location, which is about 3.5 miles west of town, or west of this location. So going through the plan set, we've got our plan and profiles of the collector pipelines within the wellfield. Sizes vary between 16-inch to 12-inch, as well as 8-inch discharge collection from the well houses. So this is our final termination point as part of this project. The southwest corner, this will be that 16-inch HDB, the high-density polyethylene pipe, going back up through the well field. As we encounter each well site, we'll have the 8-inch discharge collector pipeline, pipelines terminating to our 16-inch collection, and moving our way back up through the well field, picking up each of those sites. We do have a provision here at the upstream point of our 16-inch HTP line to account for future consideration of expansion into the east well field. I know the city's under consideration looking at additional build out in that area, so we have made an accommodation here for that future planning. And then taking a turn north up and through the wellfield site, we're collecting a couple more of the well houses before final termination on the north side of the well field. Taking a look at the enlarged site plan at each well site, we've done our best to lay out a typical design layout at each of the well site facilities so that for City Guyman, simplicity, operation and maintenance. You guys will be walking into a similar scheme at each well site and well houses themselves. We're calling for double swing gates, 16 foot, to allow for vehicle access, as well as man entry swing gates for you guys to get in there as part of your daily checks and operations. So taking a look at the well house orientation, we've got entry into each of the well houses. Inside each well house will be the surface completion from the wells, the discharge piping before heading underground and then making its way through the well-filled yard and conveying together to that final 16-inch conveyance on that southwest corner. So the bottom hole completion detail as part of each well, we're calling for the gravel pack, screens, and then of course final pump setting at each well development. So well development will include that final drilling, development, and completion testing, including aquifer testing for each location as these wells are built out. So we'll have final operation and set points for what the well field can produce as part of that construction and testing procedures. Let's see. So moving into each well house footprint, we are calling for a foundation footprint of 16 foot by 10. This will accompany a foundation pad that the well house structure will be placed on top of. The well house enclosures are going to be prefab manufactured that'll just sit in place on top of the foundation after the completion of the well drilling activities and then surface completion of the discharge piping. So trying to make this quick and easy for everybody as part of this well house design. These come prepackaged, shipped, and ready to go, and they'll set in place on top of those foundations. Well house foundation will also include a stoop at the door access and a splash pad as well for the drain lines that'll come off that surface completion for the well. So taking a look at the process mechanical for the well, I know this is probably kind of small for you guys on the screen, but we've got shown here, we'll have submersible pumps located at depths between 400 and 500 feet deep, depending on each well location. That motor will then, and pump will then pump the water through a 6-inch discharge line that'll head to the surface completion, which will include a pressure relief as well as a sampling location for each well and pressure assembly and a flow meter for that data collection and logging for activities at the well before its final termination into the well-filled collection system. All right, this is the exciting bit that everybody turns to as part of every page, or in the plan set, the page everybody turns to. So this is what it looks like inside the well house as part of the mechanical layout. We've got the surface completion, if you guys want to take a look at the section view at the bottom right. We've got the surface completion showing the well penetration through the floor. This will be what we call the upper surface termination before it goes through the discharge piping within the well field or the well house before final termination out the other side of foundation and collecting subsurface in the yard. So we've got the configuration here with discharge headed through 8-inch ductile iron inside the well house with the pressure assembly, the check valve and backflow preventer going through the pressure assembly for pressure reading and then flow meter for quantity of the water being produced from the well before final transmission through the well field. These prefab enclosures are FRP. They're the fiber reinforced poly. They come shipped as is, as described. They're a great, what we call plug and play system. So after the completion of the well, these will be set in place on top of the foundation, and then the final discharge piping and everything just hooked up and plugged in and ready to roll. What we're showing here, this is part of that 16 by 10 footprint. We've got a 4-foot access door, which will be centered on the well bore itself. So operators, when you guys walk in there, you'll be able to see the well itself and then walk in there with plenty of room to operate and maintain as you guys need to inside with that discharge piping. And of course, that ancillary equipment that'll also be located inside the well house. We're also calling for a access hatch that'll also be centered on the roof over the borehole itself. So for operation and maintenance, for you guys to pull that submersible pump or local certified drillers to be able to pull that pump out of the borehole. You guys all have access to be able to pull that and not have to worry about taking the whole roof off or even the building or anything like that. It'll be easy pulling maintenance for that on the pump. So inside the well house design, we've got all major electrical components shown here, including lighting, interior and exterior. We've also got our provisions for main circuit panels, the transformer inside there, as well as the reduced voltage soft starter, which is as a requirement by the local franchise utility, TCEC, for motors of this size, which will be over 100 horse. Taking a look at our one-line diagram, this will be our hookup for how we plan to distribute the medium voltage power across the site. So at the well field, starting at the local franchise utility, TCEC, the utility meter cabinet, which will be placed by them. We'll pick it up on the downstream side for power distribution across the site, going through our medium voltage switch, and then distributed in the same corridor along with our well field collector pipelines to each well field site for power. At each well field site, we've got a typical well house one-line diagram, which will pick up that power from the yard and then push it through all of our components requiring electric and power inside of the well field or the well house itself. And then going into our instrumentation and control strategy, we have multiple components inside of the well house, which will be on communication protocols via internet, which will be provided by fiber through the local franchise utility, PTCI. They'll be bringing their ONT, their optical network terminals, up to the well houses themselves. And then we'll grab that for internet and communication amongst our pressure assembly, the flow meter, as well as other alarms and systems inside of the well house to be communicated back to the city system, the SCADA system, for data logging, reading, and so forth. So here's what that looks like on the instrumentation and control strategy. Pretty straightforward. So we'll have data reading and logging at the well for pump status, including the pressure reading, what's coming out of the wells, and making its way through the well field. Excuse me. As well as flow monitoring and metering for how much water is being produced out of each of the wells. And that's a very quick high-level overview as part of our 60% deliverable for the production wellfield improvements. Again, this is staying up in the wellfield as part of these phase 2 improvements. Our phase 3 will be that final transmission of water back to town. Our schedule right now, so at 60%, we've got all major components shown under this package, with 100% scheduled for the last week of August. So by then, we'll have a more detailed overview and plan coordination within this set with the local franchise utilities, TCC and PTCI, as well as some additional site plans and layouts for final locations of electrical equipment and things like that within the yard. But yeah, this was a pretty comprehensive first deliverable of the 4. So for phase 2 and phase 3. Phase 3, which is also happening concurrently right now, under 60% with a schedule to delivery the first week of September to the city. So, and then we'll move to 100% designs, which the city will have a chance to review as part of the signed sealed set ahead of going to the state for review and then out for advertisement and construction. So that's where we're at.
Fantastic.
And our current, do you want estimated construction cost as well?
We could go over, just hit the tops of it, yeah.
Okay,
please.
so where we're at right now as part of 60% design for phase 2 is just shy of 15 million for this package. And then we're looking at about 15 and a half for the next package as part of phase 3.
Very well, very well.
Yeah, awesome.
I know there's been concerns about materials because of supply chain issues. Do you want to just kind of hit on the top? I mean, we've had the discussions, but your opinion on?
Sure. Yeah, we absolutely can. So over the last couple months, we've been, of course, watching the state of the industry quite closely, and of course related to government regulations and tariffs and seeing what's going on with the availability and pricing of materials. Material selection, at least as part of this first package, what we've landed on specifically for HDPE pipe at the large diameter sizes and things, there seems to be quite a material availability, and it's cost comparative or to cost competitive to everything that's on the market right now. So that was a selection for pipe material, as well as our enclosures, trying to get that prefabbed system complete and in place and delivered on site for quick and easy installation, trying to cut the schedule where we can, especially in construction. And then I know we were talking about the pump selection as well, taking a look at our submersibles versus vertical turbines. trying to find things that are quick, in stock, and readily available on the shelf, or trying to help meet those schedules and expedite. Any other points, Mike, that I'm missing on that? I know we've had a lot of conversations on those things.
We've had a ton of conversations, but that was our main concerns there, what, a couple of 3 months ago, was the supply and the tariffs and stuff, so sounds like to me we're headed in the right direction on that, so.
Doing what we can.
Yes,
Yeah.
definitely.
Yep, we do. Yeah, we've got a good relationship with the HTP manufacturers local to you guys, which will be
Very good,
nice.
yep. Well, at this point in time, I will probably take a few questions, but I want to just compliment the team. And when I say the team, I mean, this team is probably consistent of anywhere from 50 to 75 to 100 people. I mean, everybody from the mayor and the state of Oklahoma, our consultants, Kurt and Susan. We appreciate everything that's been going on down in Oklahoma City. Staff has did a magnificent job of staying current and knowledgeable of what's happening and on this project, because this is going to make the future of Guyman for the next, I'm going to say, quite a few years.
Within all of our lifetimes and beyond, we hope.
And so this is historic. What we're going through right now is historic. Where our grandchildren and will have a water supply, and that will continue the quality of life in Texas County. So my many thanks from me, myself, that to the state of Oklahoma, the city of Guyman, and all of my staff. I just can't say enough about it. So, and plus, and Adura too. You've been a great help.
We'd love to piggyback on that as well. Yeah, City of Guyman, you guys have been awesome. Guyman Utilities Authority on helping bring this project to fruition, as well as TCC and PTCI, and I know we've got surrounding and adjacent landowners as well. Everybody's cooperation and support in this has been it's awesome to be a part of. To be totally frank. Good.
Any questions from the galley? Mac? No.
Mike,
Yes.
I just wanted you to know that I'll make one more phone call to ODOT. Don't get off their hind dance. I'm going to jump up down on somebody's desk.
That will be a welcome phone call.
I just want you to know that's on my radar right now. That's one of the things I'm doing today.
Okay,
I
perfect.
sent them that video, everybody that needed to see it, and I put in there, we just missed another fatality by a whisper, and I've heard crickets back. So if I can't get some type of commitment by this afternoon, then I'm going to go see Tim Gatz.
Mr. Gatz will be here in Guyman today at 1:30. We have official ribbon cutting at 1:30 for the Highway 54 project today at 1:30. So.
Do you feel comfortable putting a bug in the ear?
Oh yeah, that's not a problem. Not a problem.
Send those videos to the engineers, and they need to do something.
Exactly. The conversation that's happening right now, every 2 weeks, we have a call in, and we talk about, and mainly the Mesa Water Project, but we're also talking about other things that affect Guyman, quality of life issues here in Guyman. And what Kurt McKean with M&P Consultants was talking about is a proposed traffic signal on Southwest 5th and Highway 54. And so we talk about a lot of different things, but I'm sorry, I'm just reading my computer screen. But this happens every 2 weeks. I think we're going to forego the one today. It'll be the first one in 2 years we've canceled, but I think this has pretty well survived that today. So, but anything else from the galley or anybody that? Even on the Teams meeting? Staff, do you have any comments now? Okay. I know staff has had the set of the 60% plans now for about a week now. I think staff's going to probably convert after this meeting today online and have a one-on-one with the consultants and engineers. So if there's not anything else come before, we'll just stand adjourned. Thank you very much.
Awesome. Thank you, everybody. We appreciate it.